All right, so for years, we've all been watching. We've seen the launches, the RUDs, and the absolutely awesome successes of that colossal Starship rocket rising out of the Texas mud. We've been told the grand vision is Mars. And more recently, we've been told Starship is NASA's ride for astronauts heading back to the moon. That's been the official story. But what if that's only part of the architecture? What if the real objective of the first starships to land on the moon isn't just to drop off a crew, but to be the outpost? For months, while we've been focused on Raptor tests and tower construction, a parallel development track has been moving forward, mostly behind the scenes. And this isn't just about the rocket anymore. We're now seeing the evidence that SpaceX has been designing and testing a whole suite of systems with one goal: to turn the Lunar Starship itself into humanity's first operational foothold on the moon. This isn't a plan to assemble a base piece by painful piece. The plan is to deliver a foundational habitat, ready to go, in a single flight. The old way of thinking about this, slow, complex, incredibly expensive, is being completely overturned. The race back to the moon is heating up, and it's not just about national pride anymore. It's about strategic presence in cislunar space. And in this game, SpaceX isn't just building a faster vehicle. They're changing the rules. What they've been building could let them establish a human foothold on the moon years ahead of anyone else's schedule. So what is this blueprint? What are the systems that turn a rocket into a home? And what does this mean for our future out there? This is the breakdown of what's been happening. So to get what's happening, you first have to understand the public-facing story. Officially, SpaceX is a prime contractor for NASA. Under the Artemis program, the big initiative to get us back to the lunar surface, SpaceX won a multi-billion-dollar contract to develop the Human Landing System, or HLS. Its job is to rendezvous with NASA's Orion capsule in lunar orbit, take astronauts down to the surface for Artemis 3 and 4, and bring them back up. Now the timeline has been a moving target. Artemis 2, which is the crewed flyby, is slated for early 2026. The landing itself, Artemis 3, is officially on the books for mid-2027 at the earliest. On the surface, this is all pretty straightforward. NASA builds the big rocket and capsule, SLS and Orion, and SpaceX provides the specialized lunar taxi for that final leg of the journey. This narrative has been the bedrock of what we've all been following for years. But from an engineering standpoint, something about this always hinted at a bigger ambition. Why would you build the largest, most powerful rocket in history, a vehicle with unprecedented lift capacity, just to use it as a temporary lander for a few days? The sheer scale of Starship always pointed to something much grander. And now, the pieces are starting to fit together. And what we're seeing is a deliberate, two-path development strategy. What we see at Starbase in Boca Chica, the rapid builds, the test flights, the failures, and the incredible successes, that's the public-facing development of the core Starship system. It's that raw, iterative process of making the rocket work. And it's largely self-funded. But there's another track, a quieter one, funded by that fixed-price NASA contract. This is where the HLS-specific Starship is being built out, tailored to NASA's requirements. and it's happening mostly behind closed doors, which makes sense to protect a competitive advantage. As some concerns about delays started to surface from NASA officials, SpaceX had to pull back the curtain a little. In a progress update, the company showed it had quietly completed 49 major HLS program milestones. These weren't just software reviews. These were full-scale hardware demonstrations. They tested things like the landing legs on simulated lunar soil, the elevator the crew will use to get down to the surface, and most telling of all, full-scale cabin mock-ups with life support systems running. So you have to ask, why invest so much in systems designed for longer stays if the plan was just a short visit? Why build a machine with the internal volume of a small building if it's only meant to be a taxi? The official story was never the full story. It was the baseline mission. From the beginning, the lander was designed to be the destination. All right, so this is the core of it. SpaceX isn't just building a lunar lander. It's building a vertically integrated, fully equipped skyscraper and flying it to the moon. The hidden systems are all designed to convert the rocket that gets you there into the habitat you live in. Let's break down the 3 pillars of this design. The single biggest challenge for a moonbase has always been launching all the stuff you need from Earth. The old concepts had dozens of separate modules, landing them, and then using robots and astronaut EVAs to assemble everything. An incredibly complex and expensive process. SpaceX's solution just sidesteps that whole problem. The base is the rocket. The Lunar Starship, without its heat shield and flaps, is a cavernous structure. The number that's a real game changer is this: over 600 cubic meters of pressurized, habitable volume. To put that in perspective, that's about 2/3 of the entire habitable volume of the International Space Station. A station that took more than a decade and dozens of launches to build. SpaceX is planning to deliver that in a single trip. And this isn't just an empty can. The renders and milestone reports are showing a sophisticated, multi-level interior. You can think of it as a prefab high-rise with designated areas for crew quarters, labs, medical, and storage. The design cleverly uses the massive space where propellant tanks would be and turns it into a shirt-sleeve environment for the crew. Getting in and out is also a huge upgrade. The design has dual airlocks for redundancy and a high-traffic gateway to the surface. And a key part of the recently shown tests was a large integrated elevator system. This is essential since the crew quarters are way up high. This thing isn't just for people. It's a cargo lift, able to lower rovers and heavy science equipment from the payload bay down to the ground. That one innovation solves a massive logistical problem for surface ops. For years, the idea was that Starship could be a mobile home on the moon. But the reality is far more ambitious. This is a foundational, stationary habitat, the first pillar of what Elon has called Moonbase Alpha. It gets there fully assembled and ready to go. Surviving on the moon is more than just having a roof. The lunar environment is incredibly hostile. You've got massive temperature swings, micrometeoroids, and deadly cosmic radiation. A base needs robust life support and a continuous, reliable power source. Again, the traditional plan was to launch these systems separately. The genius of the Starship as a base design is that these systems are integrated from the start. The milestone reports confirm they've been doing full-scale demonstrations with people inside a cabin mock-up, testing everything from air distribution and sanitation to humidity and thermal control. They've even measured the acoustics to make sure the habitat is livable, not just survivable. This isn't theoretical. This is hardware being tested right now. For power, solar panels are the start, but the lunar night lasts 14 Earth days. That means you need massive batteries. But this is where the forward-thinking part of the architecture becomes clear. That 100-ton cargo capacity means Starship could, on a future mission, deliver the infrastructure to power the base long-term. This includes the possibility of landing a small, next-gen nuclear fission reactor, which is a technology NASA and other partners are actively developing for this exact purpose. A single one of those could power a base for years, sun or no sun. So the Starship base isn't just a passive shelter. It's an active, self-sustaining machine designed for long-duration stays, not just the weekend trip. All right, the ultimate key to a permanent presence on the moon is breaking the supply chain from Earth. A base that needs constant water, air, and fuel from home will never be truly self-sufficient. This is where in situ resource utilization, or ISRU, comes in. It's the idea of living off the land, and the Lunar Starship is designed to be the ultimate ISRU enabler. The Artemis missions are targeting the moon's south pole for one big reason. We believe there are huge quantities of water ice in permanently shadowed craters. That ice is lunar gold. Break it down into hydrogen and oxygen, and you get breathable air, drinking water, and most critically, rocket propellant. This is where Starship's incredible cargo capacity becomes the ultimate game changer. It's designed to carry up to 100 metric tons of payload to the lunar surface. That's enough mass to deliver the initial ISRU hardware, excavators, rovers, processing plants in one go. Instead of a dozen small missions, Starship could land a functional mining operation right next to the habitat. So the vision is clear. The first Starship lands and establishes the habitat. A second cargo Starship could land nearby and deploy the mining gear. Robots start excavating ice, which gets processed into liquid oxygen and methane, the exact propellants Starship runs on. This creates a self-sustaining cycle. The moonbase can refuel Starships for the trip back to Earth, or more importantly, for trips deeper into space, to Mars. The moon stops being just a destination and becomes a celestial gas station. The Starship isn't just a base. It's the anchor for an entire industrial infrastructure on another world. This isn't sci-fi. It's the engineering blueprint they are actively building. A habitat, life support, and ISRU capability are incredible. But none of it matters if you can't get this thing to the moon in the first place. The final, critical piece that makes this whole vision possible is orbital refueling. A fully loaded Starship, ready to go to the moon with 100 tons of payload, is too heavy for even its own super heavy booster to send there directly. It can get to low Earth orbit, but its tanks will be nearly empty. To make the journey, it needs to get gas in space. For years, this has been the most unproven part of the whole architecture. The plan is as ambitious as it is elegant. First, SpaceX will launch a dedicated depot Starship into a stable orbit. Then, a series of tanker Starships will launch, rendezvous, and dock with the depot, transferring their propellant. This could be repeated up to 10 or even 16 times, filling the depot's massive tanks. Once that depot is full, the crewed Lunar Starship launches. It docks with the full depot, tops off its own tanks, and then performs the trans-lunar injection burn to start its journey to the moon. NASA itself has identified this as an essential capability. For a long time, this was just on paper. But now we're seeing real progress. During its third test flight, SpaceX successfully demonstrated an internal transfer of liquid oxygen between tanks inside a single Starship. A crucial first step, and according to both NASA and SpaceX, a full-scale ship-to-ship fuel transfer test is now being targeted for 2026. That demonstration will be the final proof of concept, the moment the entire architecture is validated. This is what makes the Starship base possible. It lets you trade the complexity of on-orbit or surface assembly for the logistical challenge of propellant transfer. Instead of building a base on the moon, you build it on Earth, perfect it, and then just fill the tank and fly it there. This is a complete paradigm shift. We are watching the transition from short visits to permanent settlement happen, and it's happening faster than anyone really predicted. This is a monumental moment, and it's just the beginning. If you're as fascinated and excited by this future as I am, make sure you're subscribed and have notifications turned on. You won't want to miss our upcoming dives as we continue to track how we actually become a multiplanetary species. Now, back to the new space race. All right, so SpaceX isn't doing this in a vacuum. This whole plan is unfolding against the backdrop of a new, incredibly competitive global space race. But unlike the Cold War, this new era is a complex ecosystem of private companies, national agencies, and strategic alliances. The most significant rival to SpaceX in heavy lift is Jeff Bezos's Blue Origin. While SpaceX has dominated the headlines with its rapid testing, Blue Origin has been methodically developing its own monster rocket. New Glenn, this 98-meter-tall rocket, is a direct competitor, with a reusable first stage powered by 7 massive BE-4 engines. New Glenn's development has been slower, but it's hitting major milestones. Now, all eyes are on New Glenn's second flight, which could be as early as November 9th, 2025. This isn't just a test. It's the rocket's first operational mission, carrying a crucial NASA science payload. A successful mission will prove New Glenn is ready, and it has a long manifest of customers waiting, including Amazon for its Project Kuiper constellation. Blue Origin also has its own lunar ambitions. The company plans to launch its uncrewed Blue Moon Mark 1 lander and holds a major NASA contract to develop a second human landing system for later Artemis missions. This ensures there's competition and redundancy. The rise of New Glenn means SpaceX won't have the super heavy market to itself. The competition is real, and it's heating up. This new ecosystem isn't just about rivalry, it's also about collaboration. And New Glenn's second flight is a perfect example. The primary payload for that mission is a pair of NASA spacecraft called ESCAPE-8, which are headed to Mars to study its magnetosphere. And here's where the web gets interesting. The spacecraft are a NASA mission launching on a Blue Origin rocket, but the spacecraft themselves were designed and built by another key player, Rocket Lab. Rocket Lab, famous for its Electron launcher, has expanded dramatically into spacecraft manufacturing. Their involvement in a flagship NASA science mission launched on a brand new heavy-lift rocket from another private company perfectly illustrates the modern space paradigm. It's a network of specialists. NASA sets the goal, Blue Origin provides the ride, and Rocket Lab builds the hardware. This model allows for faster and more efficient development. Beyond the commercial race, a third competition is taking place: the strategic importance of cislunar space. The region between Earth and the Moon is now officially considered a priority domain by the U.S. Space Force. As other nations push toward the Moon, the ability to monitor and defend assets in that region has become a top security priority. Enter companies like Maryland-based Quantum Space. They are preparing to launch their first Ranger spacecraft in 2026. This spacecraft is designed for advanced remote proximity operations, maneuvering precisely near other objects in space. This is a crucial capability. For defense, it can support sensor payloads for tracking. Commercially, the same tech could be used to service satellites. This, along with other projects like the Air Force's RCAT-CS constellation, shows a determined effort to establish domain awareness and control over the Earth-Moon system. The race to the Moon isn't just about science labs. It's also about securing the ultimate high ground. All right, so let's bring this all back. The realization that Starship is designed as an all-in-one foundational outpost isn't just an interesting engineering detail. It's the single most disruptive factor in this new space race. It changes the timeline, the economics, and the strategic calculus. By collapsing the construction phase into a single launch, SpaceX drastically accelerates the schedule. While others are planning multi-launch campaigns to assemble a base, SpaceX can establish a significant, long-duration habitat in one move. This could give the United States a profound strategic advantage by getting there first and staking a claim to resource-rich locations. More importantly, it validates the entire philosophy behind Starship: full and rapid reusability. As launch costs plummet, resupply missions or delivering more base modules becomes economically feasible in a way that was never possible before. And finally, this isn't just about the Moon. The Moon was never the final goal for SpaceX. It's always been a proving ground. Every system being developed for the Lunar Starship base, the long-duration life support, the ISRU capabilities, the power systems, is a dress rehearsal for Mars. The Moon provides a relatively close place to test and perfect the hardware needed to build a self-sustaining city on another planet. The moon base isn't the endgame. It's the field test for a multi-planetary civilization. For decades, the dream of living on the moon felt like something from science fiction. We imagined slow, painstaking construction over generations. But the hardware is telling us a different path is being forged at a breathtaking speed. SpaceX is delivering a turnkey lunar outpost. The revelation of these integrated systems, the colossal habitat, the advanced life support, and the logistical linchpin of orbital refueling, means the dream of a human presence on the moon is no longer a distant vision. It is an engineering reality being built in hangars and tested on launch pads today. We are on the cusp of a new era. The jump from temporary visits to a permanent foothold is about to happen, and it will happen in a single giant leap. The first landing of a Starship on the moon won't just be another set of footprints. It will be the delivery of humanity's first home on a new frontier. The plan is hiding in plain sight, and the future is arriving a lot sooner than we thought. Great stuff, guys. Thank you for watching. If you found this breakdown insightful, hit the like button and let me know in the comments what you think this all means. And as always, subscribe for more deep dives into the tech that is taking us to the stars.